Gravity doubles in a single heartbeat. The world suddenly feels impossibly heavy. Your arms drop like they're filled with lead. A coffee cup slips and shatters on the floor. Birds outside tumble from the sky mid-flight. Every building on Earth groans under invisible strain. This is the day gravity became twice as strong, and almost nothing on our planet was built for it. The consequences begin within the very first second. What unfolds next will reshape the entire Earth. You try to stand, but your body weighs double. Muscles strain to hold up bones, never designed for this load. Your heart struggles immediately. Blood pools in your legs, and your head feels strangely light and dizzy. Across the world, people sit down without thinking. The instinct is universal, because standing suddenly feels exhausting and unsafe. Children cry, confused by limbs that refuse to cooperate. Pets freeze low to the ground, ears pinned back. Outside, the sound is wrong. Everything is quieter, heavier, slower, as if the world is wading through water. Leaves snap from trees under their own doubled weight. Branches groan, then crack, raining down across forests and streets. Rooftops sag. Old wooden homes buckle inward, their beams unable to carry twice the load they were engineered for. Skyscrapers shudder, but mostly hold. Engineers built safety margins, though cracks begin spidering across concrete and steel. Bridges are different. Many were designed near their limits, and several around the world fail within minutes. Cars feel like tanks, tires flatten, suspensions collapse, and highways fill with vehicles that simply cannot move properly. Planes in the sky are in immediate trouble. Lift depends on gravity, and suddenly every aircraft is twice as heavy. Pilots push engines to maximum thrust. Some manage emergency landings, but many cannot stay airborne long enough. The oceans feel the change too. Water is heavier, so waves grew shorter, steeper, and strangely sluggish along every coast. Tides shift dramatically. The moon still pulls, but Earth now pulls back twice as hard against the seas. High tides shrink, low tides deepen. Coastlines reveal seafloor that has not seen sunlight in centuries. The atmosphere compresses downward. Air molecules are pulled tighter to the surface, thickening the lower sky. Air pressure climbs sharply at sea level. Your ears pop, and breathing feels denser, almost syrupy in your lungs. But high altitudes empty out. Mountain air thins faster than before, and climbers above the clouds gasp for oxygen. Weather patterns begin twisting. Storms form lower, tighter, and more violently as the atmosphere squeezes into a thinner shell. Clouds hang heavier in the sky. Rain falls faster and hits harder, drumming roofs with surprising force. Rivers run differently. Water rushes downhill with doubled urgency, carving banks and flooding valleys within hours. Waterfalls become thunderous. Niagara roars louder, its spray pinned closer to the rocks instead of drifting on the wind. Volcanoes feel the squeeze. Magma chambers experience new pressures, and some restless volcanoes begin venting ash and gas. Earthquakes ripple worldwide. Tectonic plates settle under heavier loads, and faults that were quiet suddenly slip awake. Meanwhile, every living thing is recalculating survival. Biology evolved under one gravity, and doubling it changes nearly every rule. Large animals suffer most. Elephants, giraffes, and horses struggle to stand, their massive frames strained beyond design. Insects, however, barely notice. Ants still scuttle, beetles still climb because their tiny bodies handle gravity easily. Birds are in crisis. Most cannot generate enough lift, and flight becomes labored, brief, or impossible for many species. Trees are quietly dying. Water cannot climb their trunks as easily, and the tallest giants begin wilting from the top. Redwoods are in serious trouble. Their height depends on gravity being gentle enough for sap to reach the crown. Within days, the tallest forests dry out. Smaller, sturdier trees survive, while giants slowly lose their upper branches. In the oceans, whales feel suddenly enormous. Water still supports them, but surfacing to breathe takes far more effort. Fish mostly thrive. Buoyancy protects them, and the deep sea barely notices the change at all. But coral reefs shift. Heavier water flows differently, reshaping currents that feed and cool the delicate ecosystems. Back on land, humans adapt quickly. We sit more, walk slower, and learn to move with careful, deliberate motion. Lifting groceries feels like weight training. Climbing stairs becomes a serious workout, leaving everyone breathless at the top. Falls become genuinely dangerous. A simple trip hits the ground twice as hard, so caution becomes a global habit. Sports change overnight. Basketball players barely leave the floor, and high jumpers clear heights that look almost comical. Marathons disappear. The human body simply cannot run 26 miles under doubled weight without extraordinary training and recovery. But strength sports flourish. Anyone who can lift in this new world becomes a legend of raw, undeniable power. Would you want to experience a day in this heavier world? Tell me honestly in the comments below. Now picture the longer consequences, because Earth itself is changing, not just the creatures living on its surface. The planet compresses slightly. Stronger gravity squeezes rock, and Earth's radius shrinks by a small but measurable amount. Mountains shorten. The tallest peaks cannot hold their height against doubled pull, and erosion accelerates across every range. Everest slowly loses meters. Over decades, the Himalayas settle lower, reshaping the roof of the world. The moon notices too. Earth's grip on it strengthens, pulling our companion into a slightly tighter orbit over time. The moon drifts closer. Tides grow even more extreme, and lunar eclipses become more frequent across the night sky. Eventually, the moon stabilizes, but its new closeness changes nightlight forever, glowing larger and brighter above us. The sun's pull weakens by comparison. Earth itself becomes gravitationally louder, though our orbit around the sun barely shifts. Satellites are in immediate trouble. Their orbits depend on precise gravity, and doubling Earth's pull yanks them downward fast. The International Space Station cannot hold orbit. Astronauts evacuate quickly, while the station spirals toward atmospheric re-entry within weeks. GPS satellites fall too. Navigation collapses worldwide, and ships, planes, and phones lose their invisible guide in the sky. Space launches become brutal. Rockets need roughly twice the thrust to escape, making orbit a near-impossible engineering challenge. Our space age pauses. Reaching the stars suddenly demands fuel, materials, and physics we have not yet invented. But on Earth, life finds rhythm. Months pass, and humans begin redesigning everything around the new gravitational reality. Buildings get shorter and wider. Architects favor stout, stable shapes over soaring towers that no longer feel safe. Furniture becomes lower. Chairs, beds, and counters drop closer to the floor because falling is now a serious risk. Shoes change completely. Soles thicken, ankles get more support, and high heels vanish from every store overnight. Vehicles transform. Cars sit lower, tires widen, and engines grow stronger to push doubled weight along the roads. Aviation reinvents itself. New aircraft emerge with massive wings, powerful engines, and shorter, more cautious flight paths. Agriculture adjusts slowly. Crops that grew tall now grow squat, and farmers breed sturdier wheat, corn, and fruit trees. Livestock changes too. Smaller, denser animals thrive, while breeders quietly retire the largest, heaviest breeds from their fields. Human bodies begin adapting. Bones thicken in growing children, muscles strengthen naturally, and posture shifts toward a lower center. Future generations look different. Slightly shorter, sturdier, more compact, shaped by a world that pulls twice as hard. But the deepest change is invisible. Earth's core feels stronger pressure, and its molten layers churn with new intensity. The magnetic field strengthens. Auroras dance brighter and farther from the poles, painting skies above cities that never saw them. Volcanic activity rises globally, the planet vents more heat, and ash occasionally cools summers in unexpected corners of the world. Climate patterns reorganize. Thicker low atmosphere traps heat differently, and scientists spend decades mapping the new normal. Some regions grow wetter, others dry out, and humanity slowly migrates toward the gentler, more livable zones of the planet. Yet life persists. It always does, because biology is astonishingly stubborn when given enough time to adjust. A century later, the heavier Earth feels normal. Children born into it never knew the lighter world be lost. They read about old gravity in history books. Stories of soaring jets, towering trees, and astronauts seem almost mythical. They marvel at photographs of redwoods, of skyscrapers piercing clouds, of humans leaping joyfully into the air on playgrounds. And here is the quiet truth. Our real gravity is a delicate, perfect setting we almost never think about. It is strong enough to hold our atmosphere, gentle enough to let trees rise and birds fly. It lets oceans move, mountains stand, and bones grow long. Every detail of life depends on its exact strength. Doubling it would not end the world, but it would rewrite nearly everything we love about living here. So the next time you jump, notice the lift. That small moment of weightlessness is a gift of physics. Every step you take is a quiet negotiation with gravity. And right now, gravity is being remarkably kind to you. Would you want to live long enough to see Earth recover from such a change? Share your thoughts below. If this thought experiment stretched your mind, subscribe and ring the bell for more big what-ifs. Because the universe is full of impossible questions, and the answers are stranger and more beautiful than we imagine. Gravity is not just a force. It is the silent author writing the shape of everything we know.